New York, extracting the signal from the noise. It's theCUBE, covering Spark Summit East. Brought to you by Spark Summit. Now your hosts, Dave Vellante and George Gilbert.
Spark Summit East, this is theCUBE. theCUBE goes out to the events, we extract the signal from the noise. This is day one for Spark Summit East. We're running a crowd chat, crowdchat.net/Spark Summit. John Furrier's in there, going crazy with Burt Lattimore. We are here, wall-to-wall coverage. Anjul Bhambhri is here, he's the Vice President of Engineering at IBM, focused on big data. Anjul, great to see you again. Thanks for coming back in theCUBE.
Thank you for having me.
So IBM, are you guys doing anything in Spark?
Hey!
Some investments that you've made, so give us the update. What's happening?
Sure. I mean, you know that we've been, since 2010, really been focused on, how do we help our customers with big data, with analytics, and we embraced Apache Hadoop, and then, several years ago, we felt that Spark is really a game-changing technology from an analytics standpoint. So we've embraced Spark. We are re-platforming our products on Spark. We opened a Spark Technology Center in the beautiful San Francisco, so you cannot miss that.
We actually were there, did a short interview with Rob Thomas.
Yeah. So that's on Market Street. And that's where we have set up a team which has committers, and they are working in the open source. So, all the way from fixing bugs to contributing to Spark R, Spark SQL. So there is a lot happening there. We, last year open sourced SystemML, which is where we really want the machine learning community to embrace it and extend it further and integrate it with MLI. And that's like a SQL for machine learning. That's how I would like to describe it. And it has a very advanced machine learning algorithm optimizer. And of course, we are helping our customers understand Spark, where to leverage it. We also ship it as a part of our products, both on-prem and on the cloud. So we ship it as a part of Big Insights, which is our Hadoop offering, so that customers, as they need to transition from MapReduce to Spark for more real time, they can do that. And we have Spark as a service on the cloud. So that's...
So SQL is like the killer app. You must get, so big demand for Spark SQL, is that right?
That's true, that's right.
And now you're saying that SystemML is like SQL for machine learning. So SQL, I guess I know why, but tell our audience, why SQL? Why is it so attractive to developers?
So, when you look at what people are trying to do with technologies like Spark, some of the use cases that folks start with is all around still the warehouse. And, like Matej was saying this morning, I don't know whether it was Matej or Ali, that just-in-time warehousing is a very popular use case. So the moment you come to warehousing, yes, everybody wants it to be more and more real-time, but to do ETL in the warehouse, to where Spark SQL and Spark streaming take it to a whole new level. And there are many SQL developers who are out there, and once your data is in this warehouse, SQL is still the best way for you to query it. So SQL is still very popular. And what we are doing is that we have also provided, at least from an IBM customer standpoint, we have provided connectors to DB2 and to Netezza, so that the predicate pushdown can happen to DB2 and Netezza. And we are also supporting the SQL dialect of DB2 and Netezza and in Spark SQL, so that people can seamlessly use it without worrying about where their data is.
we had Matei on earlier, and well, because certain of our management structure was temporarily unavailable, we really geeked out with him, and he was telling us about the way they do SQL, which is, they don't have the storage layer, and so they don't have all the information about the data that makes a query engine go so
The
fast.
metadata.
So right, but he said something interesting, which was they don't do the ETL to get stuff into the engine. So that whole process of loading the data is actually when they learn about the data. So if you add up all the time it takes to get stuff into a warehouse,
Correct.
if you time the whole thing, getting stuff in and doing the analysis, they're very competitive with the dedicated, got to bring the stuff in, then got to ask the questions.
Absolutely.
And that sounds like, if you educate your customers about that with Netezza and DB2, it's like a just-in-time warehouse, but with all the sources,
Absolutely.
that sounds very powerful and something that I don't think we understood before.
That's true. I mean, the traditional way used to be that you have all this data, you first ETL it into a warehouse, and that itself, writing those ETL jobs, and sort of doing the transformation so it used to be like extract, then you transform and you load it into the warehouse. So, like some of our telecommunication customers, some of those ETL jobs used to take like 3 weeks, right? 4 weeks, right? I mean, that's how the world was.
Right.
And after that, you've populated the warehouse, and then you start, doing your querying and reporting and, all the analysis. But these days, this is all about real time. So if the eliminating of that whole ETL process, I wouldn't say it's eliminated, but it's become more like ELT, that you extract, load, and then the transformation happens based on what is it that you're trying to do. So it's a schema on read as opposed to schema on write. And we just announced something called Quarks. I don't know if you heard of that. This is something that we just open sourced, and I believe it was announced yesterday. And this is a whole platform to help build end-to-end IoT applications. Right? Now, when you look at this whole, what is happening in IoT, the real-time aspect of everything is like super critical, right? Like, if you have I'm going to connect it to ETL. So, if you have, say, a heavy truck, right, which is beyond its weight limit, and it's going to crossing a bridge or something, and it's really windy, and you don't want that truck to be on the bridge because it may topple over and now all of these vehicles, right, they are transmitting data. So when you figure out that this truck should not be on the bridge, if it takes you 3 weeks or even an hour to ETL that data, query it and say that, you shouldn't really be on the bridge, I think it's too late.
Yeah.
So with, that's a simple example, but that's where you want to be getting that data, doing the analysis in real time, and be, avoiding that truck to really not even get on the bridge. And this is where, like, a classical ETL is not going to do it.
But that also requires, I think, what our CTO and co-founder calls the edge intelligence. So in that example, some of that, like weather data, may be coming from an outside feed. Where is that intelligence running to tell the truck, don't get on that bridge?
So definitely, so what we are doing is with Quarks, it has a framework, it's kind of very lightweight, which is embedded at the edge node. And you're absolutely right that the things have to be figured out there. There's no time to populate it in the warehouse and then do these kinds of analysis and figure that out.
Right. Okay.
Yeah, so we've been paying a lot of attention to the the whole edge computing piece, and even there's a step before that for IoT, which is you better have connectivity at the asset. If the windmill doesn't have internet, it really sort of defeats the purpose. I want to explore this notion we were talking about off camera of the analytics OS. What is the analytics OS, and what is your team doing there?
Yeah, so we've you had said, right, what are we doing at Spark? Well, other than the things that I mentioned, we really consider Spark to be a game-changing technology from an analytics standpoint, and we consider that to be the analytics operating system. So if you look at all the different capabilities that are in the Spark platform, I mean, those are all foundational capabilities of what an analytics application will need, right? That there's all kinds of structured data that you may have to query. So you have Spark SQL to do that. There could be unstructured, semi-structured data. And so, one can drop to the Spark core and, write your own logic to deal with that. There is data that is coming really fast where you need Spark streaming. If you're building, say, predictive models, you could make use of MLlib and machine learning. And all of these components in the Spark stack, they work seamlessly together, right? So it's not that you have one silo to deal with SQL, another silo to deal with predictive analytics, another siloed product to deal with streaming. I mean, that used to be the world before, that if you had to build an analytic application which was dealing with structured, semi-structured, unstructured, streaming data, you would need half a dozen products to bring it all together, right? And each with its own install and configuration and own language and own set of application development tools. With Spark, that is not the case. So once the data is entered, I mean, analytics is all about, you can ask all kinds of questions, right? You can say what has happened, so you can use Spark SQL. What is going to happen, so you can build predictive models. What's the next set of best actions that you should take? Now, all those questions, when you can answer just with, everything using just one foundation, I mean, that's an analytics operating system.
Well, it's an interesting move for IBM, right? Because you had all these bespoke products, and now you're saying, all right, well, we're going to invest, kind of like we did with Linux, in that one. We're going to put our muscle behind that one. How did that decision get made? Was that just... Oh, everybody said, oh yeah, great. I would expect some of the product managers who own those products would say, whoa, wait a minute.
We should bring those product managers on the cube, so they can answer those questions. No, but I mean, jokes.
It required some leadership to say, okay, we're going to do this and corral herd the cats, so to speak.
Yeah. And obviously there is a lot of very good assets that are there in those products. And over the last couple of years, we have been re-platforming some of these core products and engines onto Spark. I think you may have heard this from others too, that we did that with our ETL engine. I mean, there is a...
Is this DataWorks?
This is DataWorks, where, see the tools that Spark provides and for you to build these kinds of solutions and the speed, and then Scala being, the language in which Spark is implemented. I mean, we were able to re-platform DataWorks in about 1 year, right? Which is, it's almost like mission impossible without having the power of what Spark provides. Same thing we have done with SPSS. Like last year, we released, so obviously, first what was happening was that all the capabilities that Spark provides, each of these products, we were building those on our own, right? Now you have to do a surgery of those products and kind of, I mean, I'm maybe oversimplifying it, but you have to get rid of those layers and really re-platform it on Spark. But you still, the capabilities that are there, you don't want to throw those away. So with SPSS, what we've done is from a predictive analytics standpoint, we are pushing down to Spark core and we are combining the power of MLlib and system ML so that the predictive model execution has, I mean, this is all still early, but we've seen speed ups of 3 to 6x times. And now the sizes of the data are not, in tens of terabytes, but they are in hundreds of terabytes.
Sorry, what was the performance improvement? You said
About 3 to 6x.
3 to 6x.
Yeah,
No.
this is what we have seen just in our, engagements in the last 6 to 8 months.
3 to 6x performance and not tens of terabytes, but into
But in like 100 to 300 terabytes is what we have seen. Customers start using it, but the data sizes are only going to grow, right? So there may be at 300 today, it's going to get to 500 tomorrow.
So take SAS, which has not been rewritten, but from what I understand has this sort of like engine where you take SAS and whatever SAS generates some sort of translation layer, then spits it out into Hadoop. What are their constraints? Do they have to go native to be able to now match what you're doing with SPSS?
So a lot of, the architecture that SAS has been similar to now what Spark provides. But Spark is an open source. There's a huge community behind it, right? If you heard Mate, there are like 1,000 contributors on Spark. I mean, that is phenomenal. So, a technology that is advancing at that rate, I mean, I would personally rather be on that technology and, where smart people like Mate are behind it, than on something proprietary.
And IBM, I mean, you guys have a lot to do with that number, increasing. We're very short on time, but please.
A quick question, where you've got the Analytic OS and the wonderfully unified engine in Spark, there's some things that the Spark guys just didn't address. Manageability, storage, persistence. What's IBM's approach for, those sort of missing bits?
So, what we do is we distribute, so we have big insights, right? And that is where we have the Apache Hadoop stack. And for some of the things like, if things have to be persisted, so we are offering to the customers that at least on-prem, they could do that on HDFS. They could use Bhambhri as a way to install and configure everything. Yarn from a resource management standpoint. So that's what at least we are seeing, what the on-prem customers are doing. And then of course on the cloud, almost every cloud provider is also providing some kind of an object store. So we have Spark as a service on the cloud.
Even IBM now with the acquisition of CleverSafe.
So we have, we are offering, both HDFS as well as Swift. We are also, sort of decoupling the whole compute and the store, right? That's really the trend. So that customers can pick, right? What's their compute engine going to be? What's their storage going to be? Which resource manager do they want to use? In terms of install, configuration, manageability, we offer both Bhambhri as well as Platform Symphony. So those are the choices that we are giving to the customers.
Excellent. All right, so we'll give you the last word, Anjul, then we got to jump, but things we should be paying attention in 2016 for IBM. What are some of the milestones that you want to hit? What should observers be watching?
So, when you look at this whole analytics space, right, there is obviously the core technologies like Spark are making a lot of things, much faster that, you can in real time be making decisions. But the skill gap is still huge, right? Every customer that you talk to, and I think, it was there in the keynote as well today, that people are still finding it hard to get their arms around all of these technologies. They are very powerful, but there is complexity. And for that, the tooling that is needed so that you can really build these application end to end is going to be very key, so that all the complexity has to be hidden. So, so we are focused on that from, you can think of it as having, for the right persona, having the right kind of tools or workbench available so that they can build these applications in a much faster way. Data scientists, a lot of the programmers are looking at notebooks. We saw a really good demonstration today in the keynote as to how notebooks are being leveraged. But then there's the line of business who may not go the notebook route. So they need a way so that, the discovery and of what is the data, what are the attributes of the data, how do you get from that to insights in almost by writing no code, right? I mean, that's important. So that line of business has full control, that they can make the decisions. I mean, they want that they're making decisions in real time on fresh data. That is very important. And to be able to do that, they have to get the tools in their own hands. So that's what we are focused on.
If that happens in 2016, you guys are going to make a lot of money. Guaranteed. All right, Anjul, thanks very much for coming on theCUBE. Great to see you again.
Yeah, thank you
All right,
so
keep
much.
right there, everybody. We'll be back with George's presentation coming up. He's going to release the industry's first ever Spark forecast. All right, keep right there, we'll be right back.